Thank you, Alex. Okay, now we're recording. So on to participant updates and announcements. Anyone have any announcements they'd like to make for the group?
Yeah, I do. I raise my hand, so let me lower it here. So good morning, everybody. My name is Vivian Matuk. I'm the Environmental Boating Program Manager for both the California State Parks and the Coastal Commission. And I have two announcements. The first one is I wanted to invite everybody to check one of our latest education and outreach tools. I just included in the chat is the podcast entitled Dockside. We started this effort last year in partnership with the Parks Boating Safety Unit, as well as the San Francisco Estuary Partnership. We have developed so far 16 episodes, all of them super interesting, not because I manage the program, but in reality they are. Different topics of interest to this group include, for example, we have a shark research episode, one about whales off of the coast of California and how recreational boaters or boaters in general need to behave to avoid disturbing these magnificent giants. We also have some information about sewage, and in addition to that, we highlight efforts from women sailors like Captain Mary Rogers, who is one of the first Black women to hold commandership of a yacht club, probably in the nation. So very inspiring episode. So hopefully you all can listen to those episodes. The other project that I wanted to highlight to all of you, and I see that Bruce Fritz with the Alameda County is here joining us, so I'm very excited, is to give you an update about the effort that we have been moving forward with different municipalities, including Alameda, Contra Costa, Marin County, Orange County, the Port of LA, implementing free collection events for expired marine flares. I had presented to this group the statewide, and I even say nationwide issue we're facing, considering the fact that we don't have, specifically in California, a statewide system to properly collect and dispose of the flares. And that's something that the entire nation is facing. But as usual, California is ahead of the game. We have been working really hard as part of this IAC group. I started 10 years ago a working group with the DPR and Cal Recycle, and thanks to that, we have had the opportunity to have Cal Recycle offering local grants for municipalities that have been doing a fantastic job. And I'm super proud and honored to always partner with Bruce because Alameda has been the county in the nation doing and conducting legally, fully legally collection events, which have been fantastic. And this year alone, different municipalities conducted these collections events, and we were able to collect and properly dispose of 5,500 flares across the state. We're working on this effort with a very important and key partner, which is the California Product Stewardship Council. And in partnership with them and the two agencies that I represent, we are launching a campaign that is called the Make the Switch campaign to the electronic marine flares, which is a product that, again, to be proud of California, was the first one approved in the nation, was created here in California. So we're trying just to push from that angle in terms of education. So those are the two announcements that I have for now. Thank you, Vanessa.
Thank you, Vivian. Very interesting. And we'll make sure to put the links in the meeting notes so that you can find the information. Anybody else have an announcement or update or something they'd like to share with the group? Okay. Not hearing any. I did want to ask Chad or anyone else from the San Diego Water Board, if you could, see if you can get a hold of Jeremy Haas, and if he's having trouble with the Zoom online, he can join by telephone number, and I have his PowerPoint, so he could just say next, and we could go on to the next. And the number's on the agenda, but I can give that to you again if that helps.
I don't know what's going on with him. I've gotten no responses from him to messages, so
Okay.
maybe
Well,
move things around at this point, if that's
yeah,
okay.
we'll do that. We'll move his talk to last, in case he shows up, and hope that he's doing okay. So we will, one thing I want to mention is that the meeting notes and any materials, handouts and such, and a link to the recording of the meeting will be posted on the Coastal Commission's Marinas and Recreational Boating webpage under the archive of meetings, as soon as we're done with the meeting. And the link to that webpage is on the agenda. So let me make sure Jeremy's still not here. Nope, no sign of him yet. So Bill, would you mind taking it away with your presentation first? And I will call up your outline in just a minute.
I'll be glad to. Can you hear me okay, Vanessa?
Yes.
Okay.
Okay, can you see your outline there?
I see it.
Okay. Tell me
Go,
when
right?
you want a page down.
Okay. I'm Bill Kraus, and I'm the tech rep and distributor for Ceramcoat Marine Coatings. Ceramcoat's a company in Big Spring, Texas that's been making ceramic epoxy coatings since 1985, downhole oil field applications, military applications, etc. We're sort of a specialty house, but we cover a lot of ground. What I'm here to talk about today is the new Ceramcoat AF Marine, AF for anti-foulant marine bottom paint, as a replacement for copper bottom paint. And here's a brief summary. I'll just run down these and then ask Vanessa to remove that, and then I'll try and follow that outline as best I can. But we're going to talk about, number one, what is Ceramcoat, period. 2, a short history of bottom paint. 3, the differences between Ceramcoat AF, as we call it for short term, and copper bottom paint. A brief background of the DoD contract that led to this whole development. And then we want to talk about our old original plain Ceramcoat on boat bottoms for the past 24 years. Also, I have 4 or 5 photos I want to show you of the new Ceramcoat AF performance in the water, which I'll ask Vanessa to pull up when the time comes. And I want to discuss the cleaning cycle and longevity of the coating and how it's applied and what its general cost is. So Vanessa, let me, if you can remove that now, I'll start in on everything. Can you hear me, Vanessa?
Yes, I'm working on stopping my screen share.
Okay. And by the way, folks, while Vanessa's doing that, I have a 11-page document that's available on the entire background surrounding Ceramcoat AF, the new anti-foulant paint. Available, I can email you if you want me to, or I can send it via USPS if you'll give me your mailing address. My email number is on the document that Vanessa sent all of us. I'd be glad to respond if you want a very decent 10-page tutorial on this whole thing. Okay, shall I start, Vanessa?
Yes.
Ceramcoat AF Marine is, again, the new bottom paint offered to replace copper bottom paints. We all know the troubles we're having with too much copper in the water column in the various boat basins up and down the state. And that's all. What it is, just to say a few things, it is in fact non-biocidal. In other words, it's a non-biocide paint. It's inert. The ingredient in it is zinc oxide, which EPA has ruled as an inert product. That's why it can be called non-biocidal. But because we are a pesticide, just like a mousetrap is a pesticide, if we're going to reject marine growth, we're a pesticide. but under EPA and California DPA regulations, we're been officially accepted as a minimum risk pesticide, not requiring registration. Okay, number 2, short history of bottom paint on recreational boats. My first boat back in 1981 had Tribunal 10 as the bottom paint on it. And I remember you had to, when I had it the first time I had to repaint it, it had to be launched right away before it dried and cracked off. But that was ruled back in about 1985 as too harmful to marine growth. And so it was outlawed and replaced by copper bottom paint. And copper bottom paint went on till about the turn of the century there, about 1999, 2000, before they found out the copper, the cuprous oxide, which is toxic, was harming junior marine organisms. In particular, the microbes that attach to a boat's hull, that then algae feed upon the microbes and barnacles feed upon the algae. And it was there to drive that away, but it was too harmful. So we began an effort back in 1999 to find a replacement. And all those efforts have failed to date. In fact, I got in with our standard Ceramcoat 54, it was called. We branded it Ceramcoat 99 Marine just to show how it applied to the marine marketplace. But it is food grade as defined by FFDCA, used in meatpacking plants and food processing houses. It offered no pesticides, but it was easy to scrub, slick and hard, and it's lasted. By the way, it's the only bottom painting experiment with that's still on boat bottoms today, some 20 years later. But that was the original Ceramcoat, so please don't confuse what we had 20 years ago with what we're offering now. Now, what happened was the Department of Defense, the Army actually awarded a contract a number of years back to a company, actually a chemical department at West Texas A&M University up in the panhandle of Texas, to find a way to reject or to kill off anthrax spores for livestock feed troughs. The Army has a lot of horses and cattle and grazing lands, and they were having trouble with anthrax killing their animals. And so the chemistry department there at West Texas A&M came up with a method to do that, and it's called ion field generation. They're able to take the zinc oxide molecule, which is an unbalanced molecule. In other words, it has extra electrons in it, hence it's an ion, and concentrate that to generate an ion field, which is in effect a low voltage shield on the surface, in our case, on the surface of Ceramcoat. So actually, it was Chevron Oil, who we provide a lot of coating to for the offshore platforms, that heard about it, called us, asked us to put it in our Ceramcoat, see how it worked on their underwater fittings on their offshore platforms. And sure enough, it worked. So the president called me and said, Bill, why don't we re-enter that marine market out there in California with this new version? And that's what we have done. Boatyards are now ordering Ceramcoat AF Marine, again, abbreviated CKAF. But that's how it all came about. It's amazing how an application in one field can lead to an application in another. So what we've done then is add zinc oxide to the standard Ceramcoat Marine with the ceramic particle loading, which when it cures is about 60% ceramics. That encapsulates that zinc oxide, and zinc oxide is not soluble in water anyway, but it holds it in so it never leaches away. And in fact, we know it will last at least 10 plus years, which is a welcome thing to boat bottom people like me, who are used to having our copper bottom coatings replaced about every 2.5 to 3 years. So that's how it came about. And again, like I said earlier, the original Ceramcoat is still on boat bottoms today. It's just, you can't get rid of it. It's very tough. Now, there are some photos, Vanessa, you could show that one page of photos of Ceramcoat AF Marine in the water. Can you, that slide I gave you, can you do that? There it is.
Got it?
You got
No.
it there. If you can move it up as I talk. The first slide, folks, on the right-hand side, the whole thing is a fiberglass panel. The right-hand side is coated with Ceramcoat AF. The left-hand side is blank. There's nothing on it. And I put it in the water for 3 weeks and 4 weeks because that's the normal cleaning cycle for copper bottom paint. And the second photo shows a little grass or a minute amount of seaweed beginning to form on the right-hand side, the coated side. And on the left-hand side, there's algae starting and a few traces of barnacles. Now that's after 3 weeks in the water. In the third slide, if you can move it up, please, Vanessa. The third slide, thank you, is where it was in the water for 4 weeks. And I just took a dock hose and hosed off the ceram coated side to get rid of most of the grass. And the left side, as you can see, the algae has grown considerably and barnacles are forming. So then what I did is I pulled out a galley sink sponge from my boat where this was in the water. And I took it and just swiped off the remaining grass that was there. You know, grass gets on boat bottoms because of dirt from the water getting on boat bottoms, and it likes to grow in that dirt. You can't get rid of it, but it just swiped right off there in a matter of seconds. And of course, there's the other side with its barnacles forming and the algae. And then the final picture just shows that simple galley sink sponge that did the job. It's a boon to divers for sure. Now, the interesting thing is here that ceram coat as you see it is going to be like that every time a bottom cleaner cleans your boat bottom. He still has to go down to clean the running gear. So he's going to be down there every 3 weeks in the summer, 4 weeks in the winter. But there's not going to be any barnacles or algae he's going to have to contend with, just some seaweed, which he can swipe away. And that coating is going to last, again, we're predicting 10 plus years and longer, actually. But, you know, you lose track of boats after that long, so you can't really claim something you can't prove. But it's on boats today, the basic ceram coat, for going on 24 years. But that's how it works. So what we've done, we generated an ion field by the zinc oxide encapsulated in our ceramic epoxy coating. It pulls out a low voltage shield, which drives away the microbes. Now, with no microbes forming a biofilm on our boat bottom, then algae is not attracted because it feeds on the microbes. And if no algae attaches, then there's no barnacles that normally attach to feed on the algae. And I guess you could keep going up the marine food chain to get to a great white shark. I don't know. But at any rate, I don't want to find out. But that's how we work. So instead of using toxins in the water to kill off the marine growth, we're simply using nature's course. An unbalanced molecule that's been around for millions of years and it'll be around forever in an ion field, hence low voltage shield, to scare away the microbes, and that solves the problem, as you can see. And I'll be glad to answer questions in a minute here. Some of you may have heard that initially we used cuprous oxide encapsulated in our ceramic shell to do the same thing. It's also an unbalanced molecule. And I thought at the time that might be a more familiar ingredient to boat bottom people because all of us using cuprous oxide on bottom paint for so long. But EPA gave us a tough time on qualifying that, even though we did not leach after extensive testing. They said that, well, it's still an active ingredient and you got to register it. Gee, why don't you try zinc oxide? Well, sure enough, we did. And that's the same coating that the company developed had used to drive away anthrax. And zinc oxide actually has 2 extra electrons instead of just 1. So it works better, and it is declared inert by EPA, and the State Department of Pesticide Regulation has agreed with us in that regard. Now, again, the cleaning cycle is every 3.5 to 4 weeks, just like regular copper bottom paint, mainly to get rid of the heavy marine growth, hard marine growth on your drive shaft and your props. You can coat the rudders and the struts with Ceramcoat AF. but they're going to dive anyway to do that. And all they got to do is worry about wiping away some sea growth, some grass. And if you're underway pretty often, that's not going to even be there anyway. And again, the longevity we're saying is 10 plus years. And the nice thing is the application, it can go right on top of old hard copper bottom paint that's due to be refreshed. Not ablative bottom paint, but hard copper bottom paint, which all is a modified epoxy. We adhere to that just fine. It doesn't have to, you don't have to go through the thousands of dollars to blast it off. And it actually, it adheres better to the boat bottom than the cuprous oxide does itself. In fact, we tried it both ways, direct to a boat bottom, pull test, direct cuprous oxide, direct to a boat bottom, pull test. And we were 4 times better adhesion than the copper bottom paint. But we went on top of that, we pulled again, and we actually increased the cohesion of the copper bottom paint. So it's called adhesion instead of cohesion, or I call it cohesion instead of adhesion, excuse me. So it's not necessary to spray it. It can be rolled on and it adheres well to hard copper bottom paint. The cost is about $200 a gallon in quantity by a boatyard. It's $220 quantity 1. And that's competitive to copper bottom paint on the market. What boatyards mark it up to, I don't know. But I'm told by a number of boatyards, Bill, your cost is close enough to not make a difference. That's really about it, Vanessa. And I'll be glad to entertain any questions. But what I want to say again, folks, is if you'd like this 10-page document I have, I can email it to you or mail it through the post office to you. All I got to do is email me and tell me what you want, and away it goes. And thank you very much for listening to what I had to say.
That's great. Thank you, Bill. I did want to note that I believe I sent the handouts, the photos, a letter to marina managers and dock masters, and also an article in the log on this coating. I believe I attached that to the first save the date email announcement, but if not, it's going to be on the Marinas webpage in the archive of meeting notes. So if there's anyone that has any questions, just please unmute yourself and ask away.
Andy Short with Almar Marinas. Bill, my question is about wood boats. You know, whether, wood boats are a little different animal because they work. Unlike fiberglass boats, which are pretty stable, wood boats tend to flex and work and expand and contract. How's your product work there?
What type of service is your boat? I'm sorry.
Sorry, I'm with Almar Marinas. I'm the president of Almar Marinas. We're the largest operator of marinas in California.
But is the hull comprised of fiberglass or aluminum?
Wood.
Oh, wood.
Like tree wood.
Yeah, I tell you, we could go on that wood just fine. However, wooden boats need to be able to breathe, and we're going to shut off all air to that wood from the outside. And I've worried all these years. I've told people don't coat a wooden boat bottom because, it's going to dry rot on you. I'm afraid it might damage that wood. Our permeability is so difficult for a water molecule to penetrate. I think it's gonna hurt your wood. That's my advice. You may know more about that kind of thing than I do, but that's what I was advised a long time ago by a boatyard, and I understand it. I'm sorry.
Okay, thank you.
Yes, sir.
Hi, Bill. Can you hear me?
I can hear you.
I'm Karina from Sweden. I'm representing a company, Drive-In Boat Wash. I'm the CEO for the company. Sorry, I take the cam on. Yes. Such a nice product. I have a question in regards to your product. In Sweden, we have a sanitation of TBT 10, So my question is, can a boat with TBT still paint with this paint you have?
What is TBT?
It's 10 tributyl. It's kind of 10 It's wholly forbidden since '89 in Sweden, at least.
And
Is
here
it
in
on the boat?
California too.
Is it
Yeah,
on the boat hull now?
Many boats, mainly from those, let's say, early '80s.
Yeah,
Until
I tell you, I would have to get a sample of that and take it back to our factory and put it on a piece of fiberglass and do a pull test on it. And then put us on top, do the same thing we did to copper bottom paint, because I just don't know enough about that to give you an honest answer.
because it's very poisoned, so you can't take a piece of it, unfortunately, and it's very, very old paint. In the past, they painted the hull with that kind of paint.
Well, you know, a tributyl 10?
Yes,
TBT.
tributyl
Oh,
10.
I'm sorry.
Yeah.
Yeah, well, I didn't know there was any of that left on boats anymore. My
Oh,
goodness.
yeah. We have many in
No,
Sweden.
no, I can tell you no on that, because tributyl 10, just by the fact you had to put it in the water immediately after applying it, but otherwise it cracked. I don't trust it to adhere. I would not trust that. I would recommend that the old TBT be removed by soda blasting in your local boatyard.
Sanitation first, okay.
Yeah, I'm sorry.
Yeah,
Yeah,
okay.
we want to make sure we have a good solid substrate for the Ceramcoat to adhere to. And it's great because of its ceramics. It bites into the anchor profile provided by just scuff sanding the fiberglass boat bottom or the old hard copper bottom paint.
Okay. Could it, one last question. Many of our boats in Sweden are painted with epoxy, because we strongly suggest the boat owners to use epoxy instead of biocide color, of course. So on the whole East Coast, mainly boats are actually epoxy treated. Can we use your paint on top of epoxy? I missed that part.
The boat bottom is coated with the standard epoxy coating.
Yeah.
Or some modified epoxy coating, then we will be able to adhere to that. Once that is thoroughly cleaned and scrubbed with 60 grit paper to create that anchor profile, then as long as that epoxy is adhering to that boat hull, then we're going to adhere to that.
All right. Thank you so much, Bill. I sent you an email, so please send me the presentation.
All right.
Thank you so much.
Give me an email from you and I'll do it.
I sent it already in your
okay. Thank you.
Chat. Thank you.
Thank you.
I have a question. My name is Michael Quill. I'm at Los Angeles Waterkeeper. Bill, really interested in the product. We have a hull speed now on our vessel, a ceramic based paint. Do you think there'd be any problem with the adhesion of this product to that?
What kind of ceramic based paint is it?
It's well, it's from Hull Speed. Have you heard of that product?
I haven't.
All right, I'll check out your paperwork and see if there's any problem with its application. What I need to prep. We had to do a lot of prep to apply Hull Speed, and we've applied 2 coats of that, and I'm looking to make a move, and this sounds really promising. So I'll peruse your materials and see what I can find out.
Is it put on? Is there epoxy in it at all?
No.
Yeah. See, I just don't know it. Some of that stuff is pretty tricky. It may be that we would have trouble adhering to that. I don't know.
That's what I'm wondering. Yeah, it's pretty thin, but I'll go through your materials and maybe get back to you on that.
All right, sir. Thank you.
Thank you, man.
I'm Cleve Hardacre. I'm with Recreational Boaters of California. Certainly sounds like an interesting product there, Bill. And the question I would have is, have you made inroads with the boatyards, and the boatyards are actively promoting this product? Because I'm concerned on behalf of sort of the average boater that they go into a boatyard and they get a brand new product applied. It sounds as if applying your product is cost competitive with copper, but whatever. But there's some concern about the longevity, and you say that the longevity is going to be great, but the boater who goes in and pays the boatyard to put this coating on is taking a risk that it won't last that long. So my question would be, is Ceramcoat, in conjunction with the boatyard, offering any kind of a warranty for the product? Because, of course, a significant cost for applying the product or repairing the product would be to have the boat hauled out. So, you know, an average boater is taking a significant risk trying a product that is relatively unknown.
I understand and appreciate that question. Believe me, and I'm talking to boat yards. I've been boating for about 35, 40 years, and some of the boat yards I've talked to have told me that they don't want to change their way of doing business. They're using copper bottom paint and it makes little money for them and they don't want to change, period. And other boat yards are saying, hey, let's give it a try. Get me some customers that want it and I'll put it on for them. Now, our standard warranty, like all coating manufacturers, is a 1-year warranty. And I got to tell you, if we were to put the boat yard to put Ceramcoat on that boat bottom and it failed, it's going to fail within a few months. The bottom cleaners will make sure it fails, that's for sure, if it's not going to hold up and adhere. But if it adheres, it's going to last a long time because it's already lasted, you know, going on to 20 plus years on boats that I'm aware of, that I supervised the job 20 years ago. So, and it's on the leading edges of all the Air Force fighter wings and vertical horizontal stabilizers, nacelles. It's tough. It's the toughest coating, ceramic polymer coating around. And adding the zinc oxide is nothing more than adding pigment to it to make a different color, either white, black, gray, blue, whatever. So I don't see any danger there whatsoever. But of course, and again, mainly because we're probably on 100 different boats in California over the years with standard Ceramcoat, and the only difference is we've added in zinc oxide. And we've done a pull test on that separate from when we did the pull test on cuprous oxide and other pull tests on steel of standard Ceramcoat. And the zinc oxide does not phase it whatsoever. So if the boat hull is cleaned and prepared properly, it's gonna do better than copper bottom paint. And again, it's not like we're a brand new kid on the block. We've been on boat bottoms for 20 years. I hope that helps answer your question. But I got to tell you though, boat yard owners, managers are stubborn. They've got something going. They don't want any headaches. And the trouble is, a lot of boat yards are up and down the state worked hard with the Water Quality Control Board going back 20 years ago to help develop a new bottom paint alternative to copper bottom paint, and none of them ever worked. And what happened to those bottoms, I don't know. Anyway, so it's going to take some encouragement to boatyard managers to offer to use this product, and the pressure there is that it's still on to get rid of the copper bottom paint. And I think we can count on the water boards and the state DPR to probably force that issue someday.
So, hey, Bill, this is Greg Shem. I'm one of those stubborn boatyard guys, possibly in your description. But let me say, pardon me, I'm getting over a cold. But let me say that boatyards look to utilize what works best for its customers. Yep. We will put on any coat that you want. Okay, we have certain coatings that we have decades of experience with. We have a cooperation on a project with LA County where we've put various coats on numerous boats over the last number of years, and perhaps they might want to chime in with some of the results. And we've tested dozens and dozens of paints that have had claims that sounded way too good to be true. So we are sticking with what we have history with. Now, I understand we're putting your coat, your new formula, on 2 test boats for LA County, 2 27-foot sailboats. So we're looking forward to seeing those results. But I don't think stubborn is an accurate description. We're looking to know what works because we have to stand behind our product. And if a customer comes in and says, well, will you guarantee it for 2.5 years? And we say, well, the manufacturer's got a 1-year warranty. That means we're taking the risk for that additional year or 2 that it may or may not perform. So we're open. We've done numerous tests. so far we found the ultra low copper paints to be pretty effective and pretty minimally impactful. But we're open. We hope that your product excels and becomes that magic bullet that solves our problem. That would make us very happy. So that's kind of what I wanted to jump in and say.
Thank you very much. Yes, I just got a call from, I guess, Scott of your boatyard the other day about coating those 2 sailboats. And I'm going to come up there when that happens to make sure everything goes smooth. But that's the best way. Let's get it on boat bottoms and try it out. But again, I'm not worried about the Ceram coat coming off a properly prepared boat bottom hull, an underwater hull. I'm not worried whatsoever. And I know it works because I've been testing it for 4 years. So I think we're going to have good results, but you're right. The first olive out of the jar is always tough. I will talk to the factory and see if we can't offer some type of an extended warranty beyond the 1 year. I don't know if we on Ceramcoat, by the way, for pontoon decks on floating dry docks, we offer a 5-year warranty because we put down 40 mils. This is a 10 mil type coating. As long as it's prepared properly, the surface that is, I'm not worried about it adhering. I'll see what I can do. It's a good suggestion you made. I thank you for that. Let's try and get the warranty out there.
Yeah, there's a big world of difference between testing things on a plate and real world application. And I think you just need to get real world experience with boaters willing to take that first step. And if you can provide that kind of a warranty, my guess is you're gonna find some takers.
Thank you very much for that. I appreciate that. You know, what I'm hoping is that some of the harbors that have harbor boats in the port of San Diego, port of this city and that city that have harbor boats will volunteer to have at least one of those boat hulls coated with Ceramcoat next time they're due for a bottom paint job, just as a show of authority and show of force by the water authorities themselves. Anyway,
You bet. Thanks, Bill.
We'll get back to you on that.
Thank you.
Thank you.
I just want to chime in because I have worked with Greg trying different boat bottom paints. And if you would be interested in sponsoring a nonprofit that's looking for alternatives, we could get in on that game. We can talk about that later. We've been working with Greg.
I'll be glad to. Can you email me that information and I'll be glad to communicate with you.
Yes,
thanks very much.
Well, that was a great discussion. Any more questions or comments before we move on? Okay.
Thank you very much, Vanessa.
Well, thank you very much, Bill. Very interesting. We appreciate your talk. So, shall we move on to Jeremy Haas from the San Diego Water Board? And Jeremy, if you would like to call up your PowerPoint and share your screen, feel free to do so.
All right, thank you. And Vanessa and everybody else, I'm really sorry that I'm late. I don't really have any excuse at all. So I will try to call up these slides. If I fail, apologize in advance. If it's easier for you guys to do them, that's great too. Either way, it's totally cool. Let me see what I got here.
And the share screen button, if you don't know, is in the green button on the bottom menu of your screen. If you have difficulty, I'd be glad to pull it up for you.
All right, now, oh, good Lord. You know what? I'd like to save people's times. If you can pull it up, that'd be great. I just tried something and my whole screen went like sideways on me. Does that happen to you guys ever?
Okay, hold on a moment.
Now I don't know how to get out of it. Uh-oh.
Well, I called it up, but I'm not seeing how to start it as a presentation.
And I can't see anything right now.
Can you see my screen?
Nope, I'm having one of those moments where
You're having one of those days.
yeah.
We
Look,
can
I
see
can't.
it.
Okay, well, I'm trying to make it into a presentation.
Well, if you tell me what slide you're on, I can talk from my notes. How about
Sure.
that? Let's go
Yeah,
there.
okay.
So I'll start. The summary of this is that the regional water quality control boards are tasked with protecting and restoring the ability of state waters to support wildlife and human uses. And for decades, the board's decisions have relied upon data primarily from chemistry and toxicity to do that. And now it's time to use assessments of biological integrity. I'm reading from the summary that Vanessa provided out. So what I'm going to do is talk about a shift in our perspective in Shelter Island Yacht Basin conditions from water chemistry to biological integrity. So what I'll talk about is first, kind of broadly why biological integrity assessments are the best fit for what our regional water board is expected to do. That is our statutory responsibilities. And then how they make decisions to fulfill their role. Then we'll hear about why Region 9, that's our San Diego region, is investing so heavily in staff time and money to develop the use of bioassessment tools to support and inform the board's decisions. And then a little bit about what this means for Shelter Island. And then, Vanessa, if you're cool with it, I'm happy to take questions as I go.
Sure, that's
All right.
fine. Next slide.
Slide 2, please. All right.
Oops.
So,
okay, got it.
okay, great. So slide 2 is a shot with any luck of we got some Shelter Island maps on the left and some pictures on the right. And so our mission as a state agency is to protect and restore and enhance the quality of the water so they support these uses. So in the top left picture is an aerial shot of San Diego Bay. And you can see the Shelter Island part kind of circled in there. And then the next aerial down below it is a little slightly more zoomed in where you can get an impression for just how concentrated this marina is as a yacht basin. So many marinas in there. And then the other parts I'll try to talk about in a sec, but they just kind of reflect different perspectives from around that basin as you're looking in at hardened shorelines and soft banks and boats and various kinds of uses. So in generally, our task is really to maintain the chemical, physical, and biological integrity of state waters so they can support the uses like swimming and fishing and boating and wildlife uses too. So Shelter Island Yacht Basin is a modified portion of San Diego Bay, kind of near the mouth, as you can hopefully see there. So it does get a good exchange with the bay, with the ocean, as opposed to the far inner southern parts of San Diego Bay where there's much less mixing. Historically, it was mostly mud flats and sandbars, but the water was deep enough in parts to support a bit of a 19th century fishing trade. And then the first recreational boat club in San Diego, which later on someone from there went to win the America's Cup. Pretty exciting. And because of its location near the waterfront, this area was really one of San Diego's first neighborhoods way back when. Anyway, fast forward to about 1975 when the Clean Water Act and our water code statutes really kicked in. The yacht basin was mostly residential, which is along kind of the northwestern side, a lot of that soft bank with some intertidal rocks here and there. A lot of recreational boating, like marinas and clubs, and then services related to recreational boating and some tourism. And so a lot of those marinas in there that you see, a few are boating clubs and a few are associated with hotels and that sort of marinas, associated marinas. However, around that time, San Diego Bay itself was horribly polluted. Think, decades of raw sewage going into it, massive fish kills, wide swaths of polluted mussels along the banks that really weren't safe to eat. And generally, people didn't really do a lot of swimming or fishing in San Diego Bay. There are some exceptions, but in general, it was kind of on the edge of just getting to be what it is today. Okay, so our collective response to all that, following guidance from the Federal Clean Water Act and the State Porter Cologne Act, was to focus on the chemical and the physical conditions of the bay and to regulate discharges into it. So our response was to clean up sites and clean up the discharges going in. We focused on the chemistry and physical targets and their assessments to inform us. And however, since the 70s, both the federal and state agencies said, you know, biological targets are very important, especially for these wildlife beneficial uses, and they're going to be developed someday. And then we started funding some and testing some and discussing some, and well, now it's here. But I'm getting a little ahead of myself. So anyway, today the Shelter Island Yacht Basin is primarily recreational boating and related services, some light residential, lots of tourism. Lots of swimming and boating and fishing and good habitat value in there, a lot of birds, etc. So our task at the Water Board is to interpret the water quality and let that assessment drive our actions to protect and restore those uses. Okay, next slide, please, Vanessa. So how do we do that? So fundamentally, and as the water code lays out for us, our board makes decisions based on observations and some rational thought, just like everybody else should. Our observations, of course, are limited views of reality. You know, we don't see everything, we don't assess everything. And then subsequently, our decision-making is limited by those observations and the experiences we have. So think about, for decades, we've relied on information about chemical and physical conditions of the waters and the effect of that water on species in laboratories, with the intent and the hope that those measurements can represent the biological integrity of a water body and that our board can make good, rational decisions, good informed decisions. And that approach made sense, perfectly rational. You know, water science, since for a long time, and almost all of our water resources in the San Diego region have been centered on decisions based upon the chemical and physical integrity of those waters. So the water boards, through public processes with stakeholders, reasonably crafted many restoration plans based on those considerations. For example, many of the cleanup and abatement orders we've worked on with contaminated sediment in San Diego Bay, and many TMDLs all across the state, including the one for dissolved copper in Shelter Island. Next slide, please. So, consistent with that traditional approach, the Water Board determined that the aquatic life uses of Shelter Island Yacht Basin were impaired because levels of dissolved copper exceeded the standards established by the US EPA. And we adopted a restoration plan called the TMDL, and that plan relied on reducing levels of copper discharges from copper-based pesticides applied to boat hulls. It was an obvious and substantial, overwhelming source of that dissolved copper that was exceeding the standards and impairing, therefore, the life uses in the bay, in the island yacht basin. Sorry. Anyway, so as a result of that TMDL, the management of those pesticides has improved greatly. And in each August, the Port of San Diego has been assessing levels of dissolved copper and running toxicity tests on those laboratory organisms. So the question is, can the Water Board and the public make informed decisions about the aquatic life use in the yacht basin based on that information? Next slide, please. Now, what we measure to determine whether water quality supports the beneficial uses matters a lot. It is the lens through which we view and which we conduct stressor and source identifications and determine whether the protection and the restoration targets have been met. Now that lens evolves with time and with knowledge, of course. For example, for swimming standards, original ones were based on levels of fecal coliform coming out of public sanitation work in the 50s. And recently, a few years ago, the EPA and the state board have switched to Enterococcus and E. coli, slightly better indicator bacteria. Several years ago, the state board adopted sediment water quality objectives, which we'll talk to in a little bit, to replace only relying on chemical assessments themselves. So, in fact, both the Clean Water Act and the Port of Cologne State Water Act have built-in requirements for the water boards to evolve their plans over time based on regular review of scientific information and uses of the bays and the waters. So that's why these lenses evolve with time. And so though information was limited in the early 1970s when the Port of Cologne and Clean Water Act were adopted, federal and state governments knew that better measures of biological integrity were needed and were achievable. That is why the mission, or that is reflected in the mission of the Clean Water Act, to protect and restore the chemical, physical, and biological integrity of waters. So since then, both the federal government and the state government have been funding various ways to assess biological integrity. For example, those sediment quality objectives, which I'll talk about pretty soon. If not here. Oh, here, right. Anyway, and 3 years ago, our own regional board adopted biological water quality objectives for freshwater streams. This uses the benthic macroinvertebrates to determine the state of the aquatic life health in freshwater streams. Other states use biological integrity measurements also. In fact, almost every single state. Chad Laughlin, who's here, can answer some questions about the status of biological assessment methods in other states and can tell you which state is the holdout. But nonetheless, the point is that it is time for our collective decisions about biological integrity to be based on measures of biological integrity, not just chemical, physical, or laboratory proxies. This is reasonable, it is achievable, and it is efficient. So that's where we're going in Shelter Island and San Diego Bay. And to do that, we need to answer some fundamental questions, like what should the marine ecosystem in Shelter Island Yacht Basin look like? How would we assess that? Do we have that data to assess it now? And if not, what do we need to do and how can we get it? So our staff has been working on addressing some of these questions. And last year, Wayne Chu developed and the board adopted a plan for doing strategic water quality assessments in San Diego Bay that relies for the habitat and ecosystem beneficial uses on measures of biological integrity like this. Next slide, please. And this is my last slide. So I'll leave with a couple of examples that demonstrate the direction we'd like to go. On the left here is just dots from where sediment quality objectives were measured in Shelter Island Yacht Basin over the last couple of 5-year cycles. I'm not going to talk about what the results are, just letting you know that there were some. And these sediment quality objectives try to integrate data from chemistry, from toxicity, and from the benthic communities themselves. And it's really best calibrated for, I think, open, soft bottom areas. There are other folks on the call who can answer questions about sediment quality objectives much better than I can. But the point is that it does include measures of biological integrity within an overall assessment of the aquatic life use in the area. On the right hand is a screenshot of some eelgrass surveys that are conducted by the port, I believe by the port, every so often. And anyway, eelgrass surveys are very valuable for many agencies, including ours. They show you the extent of this really productive eelgrass habitat around the marinas around the bay. So it's good to know where it is, how much of it is it growing, is it shrinking? But what these surveys don't say much about is actual conditions. So our board and some others are developing a conditions assessment that will be tested soon in all of our coastal bays in the region. This will give us more of a direct assessment of the integrity of the biological conditions within those eelgrass beds that will help us make more informed decisions. There's lots of other work that is and has been done to look at biological communities, both in San Diego Bay and elsewhere, including previous ones in Shelter Island, which studied the benthic community relative to the levels of copper within the sediments. So those kinds of studies can happen, have happened, and are ones that we should be using to inform our decisions. So moving forward, our board wants to have a public process to discuss and consider how to rely on biological integrity assessments to inform their decisions in San Diego Bay and in Shelter Island Yacht Basin as a way to get more results from our copper TMDL. It does not mean to stop worrying about copper. We all know that copper levels in the Bay's sediment is harming the benthic community, and the biggest source of that copper is anti-fouling boat hull paints. Copper will need to be reduced in order to achieve the aquatic life beneficial uses in this basin and potentially elsewhere in the Bay. However, rather than using copper levels to determine whether biological goals have been met, we want to use measurements and assessments like these two examples that better represent the biological community within Shelter Island Yacht Basin. I'd say relying on limited chemistry to give us answers about wildlife uses is no longer reasonable. Biological targets are feasible, are in existence, can be developed, and provide much more useful information. They are the best tool to use to meet our board's responsibility for protecting and restoring water quality for the many uses of Shelter Island Yacht Basins and other areas. And that's why we're moving forward. Thank you very much.
Well, that's great. Thank you very much, Jeremy. Very interesting. And we hope to have you back for a future meeting to let us know how this is progressing. So are there any questions or comments anyone has for Jeremy?
Hi, Jeremy. This is Ray with Orange County Coastkeeper. Just a quick question. What kind of costs are associated with the biological assessments? I assume it's significantly more than just water chemistry.
Hey, Ray, how you doing?
Good.
So the short answer is I can't give you an answer because our board has not adopted a particular biological assessment to do for the Shelter Island Yacht Basin. So people on this call can give you estimates for what those sediment quality objectives cost, or for what you know, a survey of an eelgrass extent can go for. But we don't have, like, we have our freshwater biological objective methods and procedures for streams, but we don't have that similar thing for a yacht basin at this time.
Thanks. So just a kind of a follow-up. So to clarify that the TMDL as is still in effect, and you're looking to revise the requirements of the TMDL?
Okay, yeah. So that is correct. The TMDL is in effect. It's part of our basin plan, and we'll take a full rulemaking procedure to do anything to change that. What we're considering doing is amending it such that the targets that we want to achieve are biological targets. And then the theory being one of the ways to achieve that biological target would be to focus on the sources and stressors such as dissolved copper, but recognizing that just because you might eliminate copper doesn't mean you know whether the community is thriving or not. So we want to use targets because we also think there could be other management decisions that will avail themselves once you start assessing the actual biological conditions rather than just focusing on the dissolved copper. And together that leveraging might lead to a more effective and efficient restoration in the basin.
Thanks.
Hi, Jeremy. Can you hear me?
Yeah, thank you.
Yeah. Hi, I'm Karina from Sweden. I'm CEO for the company Drive-In Boat Wash. We have actually had one location in the bay you're talking about. I have another question. It's invasive species. How do you see the situation right now? Is it increasing or is it like stable?
For invasive species?
Yeah.
I'm not, I don't know. if somebody on the call like Barry or Chad have some information about that, maybe they can chime in. Generally, I think, we're looking at, I don't think we have a great idea for the suite of communities from the benthic community up to, the pelagic and the shellfish and the whole extent. But I've not, depending on how you consider the oysters there, I don't really have much information
Okay.
on that.
Okay.
We need to do those kinds of assessments.
I was just curious because in Europe generally it's a huge debate right now about it, especially in the lakes, and it's hurting our lakes tremendously. So it's spreading all over. So it was just a question.
Okay, yeah, I'm sorry. In the context of Shelter Island and copper, like I don't know if there's a relationship or not, but as you may know, we do have an outbreak of Caulerpa down in our South San Diego Bay now. I don't know if the news made it all the way over there, but for other folks on the line, they should be aware of that because Caulerpa, as you probably know, is extremely threatening to the ecosystem of San Diego Bay. And so we're trying to nip that in the bud as best we can. And it was found down in the Cays marinas, and I don't think we know whether it's in any of the other marinas yet. So that is an issue that I would say would, to your point, Karina, would if something like that got out in the bay, it would definitely deserve more attention than it would get immediate attention, more urgent attention than sort of long-term issues like copper boat paints or climate change or something to that effect.
Okay, thank you so much for your answer. Thank you.
Jeremy, I had a question. Greg Shem with the Boatyard, Marina Del Rey. Could it be possible, first of all, I think this is very enlightening and I think it's absolutely the right direction to go to, but I'm wondering if it would be a possible outcome that when you get the biological assessment tools in place, that could lead to a threshold that in translated to a TMDL might be actually a higher level, a higher hurdle. And do you think, the follow-up, I'll just throw it out there right now, do you think this in progress would somehow, or could it affect the timing of the implementation and some of the reopener meetings that we have with the water boards?
Okay, so a couple of questions in there, and the first one is I don't think so first one is I don't know what the level of copper is going to be in the future. That's a standard. But if we can base that on some correlation with achieving, a good biological integrity in the basin, we'll have a much better justification for that number than we have for the current one that's in the California Toxics Rule now. So it would be a more informed and more accurate number should one be able to come out of it. And it's quite possible that there might be a new number coming out of it or some variation of that once we can get the right data. At this point, I would say the weight of evidence is kind of up into interpretation. We have, like as I mentioned, some notion that copper levels in the sediment have impacted the benthic communities. Those kind of things need to be confirmed, of course, but that would suggest that there's too much copper in the system. And then we have some data from the port about laboratory toxicity of the water in Shelter Island, and most of it meets the lab test, except for a couple of the less well mixed and sort of dense boat areas. And so other than those two sorts of examples, I'm not sure what we have to inform us of whether we think that copper level, the standard number, might go up or might go down or really might stay the same.
Yeah, well, I think, for example, here in Marina Del Rey, I think the concern has been really focused around the dissolved copper. And I understand the benthic impacts and how that could perhaps not change much. But we seem to have a pretty healthy ecosystem up here in Marina del Rey, especially since we're a man-made artificial, habitat to start off with. Anyway, very interesting, and I think we're heading in the right direction with that approach.
Yeah, thank you for the question.
Jeremy Cleve, Hardacre, Shelter Island here. I noticed that the views you had of Shelter Island showed that there was much less stuff growing and higher levels of copper up at the head of the basin. And a number of us have consistently held that it would be beneficial to construct a conduit to allow a better circulation in the basin. Would that be consistent with the Water Board's new approach?
Yeah, thanks for the question, Cleve. Hope you're doing all right. I'd say wouldn't really be inconsistent. The point being that we want to, once we get assessments of the habitat conditions, the biological integrity, then we can figure out what the most reasonable and effective responses could be. And if somebody can show that opening up a little flow that way would be on the right track, then I'd say be consistent. I can't say whether it'd be the optimal or the most efficient one, but I don't see why that wouldn't off the bat be inconsistent. And I will say, I'm sorry I didn't get to walk through those pictures. Shelter Island is a beautiful place. For anybody who's coming down to San Diego to visit, definitely recommend you take a swing by and experience what it has to offer in person.
Okay, well, are there any last questions for Jeremy before we move on? Okay, well, let's move on to our final presentation. Dr. Ho from the San Diego State University. There you are. Would you like to show your PowerPoint and share your screen, please?
Sure. Okay. Do you see the screen?
Yes, can see it fine, thanks.
Okay. Should I start right now? Do you guys hear me well?
Yes, please, yes. And you can introduce yourself and the topic of your talk today. That'd be great.
Okay, thank you. I'm Una Ho. I'm a professor of environmental health in the School of Public Health in San Diego State University. It's a very interesting discussion that this morning so far. Today, I'm going to talk about some chemical contaminants found in the San Diego Bay marinas. And I was involved in this project several years ago. With the work was not just my own research lab work, it was actually collaborative work with Dr. Carlos Naira and Lisa Levin's group in Scripps Institution of Oceanography in UCSD. And basically my lab and their lab, we work together. And then my lab is much more responsible for chemical analysis. So that what the contaminant analysis here. The focus of the work is first of all, in terms of the contaminants, we focused on polycyclic aromatic hydrocarbons and polychlorinated biphenyls. The work that I'm going to present, those work already published. Those were published in 2017 and 2018 in Marine Pollution Bulletin. I'll share the papers with Vanessa. If you guys need the papers, please contact Vanessa. And lots of details can be found in the paper. Today, I will more like provide a summary, that what we found in the San Diego Bay marinas. So first of all, I mean, I don't think I have to really talk about too much about the introduction of San Diego Bay, because the previous presentation already covered the San Diego Bay. San Diego Bay is it's surrounded by the urbans, so you can kind of imagine there's any place that's like an urban and then heavy, high population, there always comes with the pollution, it has an airport there, and then it has military shipping activities, there's substantial commercial fleet. It's no wonder, what's probably the pollution is probably pretty high over there. So what we were thinking that the originally, that what is about those polycyclic aromatic hydrocarbon contaminants in the San Diego Bay marinas? So I'm going to just give a little bit of, just brief background about the PAHs. We call them PAHs. What they are the mostly coming from the incomplete combustions. Some of them are known to be the human carcinogens, and then PAHs are known to be toxic to ecotoxic as well, and it's one of pretty high priority pollutants. The EPA set them, as a high priority pollutants, and then PAHs can come from, and you have a very many diverse sources. So one of the kind of things like marinas, why the PAHs is definitely the boat activities, that boat activities could, the fuels could be leaked, or the combustion, that can probably produce some, the PAHs, from the activities. And also it's interesting also, the San Diego Bay Marina is also very close to the BG Road there, also airport and parking lots, all kind of stuff. So it was kind of interesting study. My research is basically doing a lot of chemical contaminants analysis, and then we are looking at the environmental monitoring, and outdoor, indoor, mostly for the human and wildlife exposure assessment. And this work is actually pretty interesting because it's focuses on the marinas, and then it has a very many sampling sites. I can show you that map in the next slide. So basically, what are the questions are? There are like 6 questions listed in the paper. I'm not going to talk, read all this stuff, but mostly they go, what are the actual concentrations of PAHs in surface sediments of the 3 San Diego Bay marinas? And then is there any kind of a spatial distribution that we need, of PAHs, and then is there any trends, this PAHs spatial distribution with the boat presence or some other factors. And then there's some kind of more like a sediment quality based toxicity, almost like a risk assessment, that kind of stuff shows that is there any potential ecotoxicological risk from that, identify the PAH concentrations in the marinas. So so here we have 3 marinas in the sites mostly. The first is the Shelter Island Yak Basin, is in the left corner. I hope you can see the map pretty well. There's a numbers like SI, and numbers. So we have about 20 more stations in the Shelter Island Yak Basin. The surface sediments were collected from there. If you're looking at the Harbor Island, we kind of had like a west stations and then east stations. So we have about 15 west stations in Harbor Island, and then we have 8 stations in Harbor Island East. The method was the surface sediments. It's basically 0 to 5 centimeter depth were collected each station. And basically, I'm going to very briefly say, you know, that all the methods are described in very detail in the papers. We just did take a 5 gram of homogenized the sediments, you know, surface sediments. It was prepared in our lab, in my lab, and then was analyzed by GC with time of flight mass spec. It's an analytical instrumentation. And then for 36 PAHs, it's important thing is that 36 PAHs included the 16 EPA priority PAHs. Okay, so this is the kind of like result of the constant total PAH concentrations among the three sites. The Harbor Island East has the highest concentrations. If you look at the average, even if you're looking at the distribution of the PAH concentration, Harbor Island is definitely statistically has much higher concentration of the PAHs. And you may see that like a one top in the Harbor Island is like has a kind of outlier concentration, which is extremely high concentration. And then the Harbor West and then Shelter Island, they're pretty similar concentrations. Okay. So we kind of looking at to the like what happened to this one station has extremely high concentration in the Harbor Island East. It was at the station that we picked it, we collected the sediments. It was just next to the small storm drains from the parking lot. So we kind of wonder if possibly that's coming from there, from the parking lot, you know, the PAHs, you know, from the parking lots, a lot of cars, and cars produces PAHs. So that's possibly related to that, you know, the parking lot and the storm water. And then this is the SIO group. They use some kind of like modeling. So what is the spatial distribution, you know, of this PAH concentrations? I hope it kind of makes sense to you guys that the graph, the map is showing the Shelter Island. You can see like the red spots. It's that kind of like what are the hot spots in each site. And if you're looking at the B, the station is the Harbor Island West, where are the hot spots there? And then the C, the site is the Harbor Island East. And you can see that like the potential, those hot spots from based on the PAH concentrations. So it's interesting portions are those hotspot gradients do not follow the distribution of the boat presence and things like that. I don't know exactly that thing because my collaborator, Carlos Narita, he actually studied the copper, you know, and then they found the copper, the relationship between copper concentration and the boat's locations and things like that. But they found that kind of a correlation, I think. But PAHs, it does not necessarily follow the same trend here. Rather than the high PAHs hotspots are shown more like the sites near the BG road or adjacent parking lots. So it's more kind of connected to the car and transportation around the marinas. You know, that's what we kind of found, and then also the storm drain as well. And then based on this data, and then what are the biological risks, you know, here, and it's basically using some sediment quality guidelines, and then using the PAH concentrations. So what it could be the biological risk there. In this study, you know, the concentrations of individual PAHs in Shelter Island and then Harbor Island West were largely below the level, you know, biorisk level. However, it's like a ERL, it's the effects range low. But in contrast, the Harbor Island East had a concentrations of several pHs between ERL, is effects range low, and effects range median. So basically, it is the level, those are levels are the between. And also the total pHs actually exceeded the ERL at station Harbor Island East 0, and it exceeded the effect range median at station Harbor Island East 8. So there are certainly some ecological risk there, you know, from the pH concentrations found in the marinas, but not whole marinas, but some stations. We followed up the study basically using the same extracts. The sediment samples were extracted, and then those were analyzed for the pHs first. But then the second question is that what about the PCBs? Is polychlorinated biphenyls? Polychlorinated biphenyls is very well-known, persistent, and bioaccumulative, biomagnifying toxicant. The polychlorinated biphenyl is an industrial related chemical contaminant. It was found in a lot, you know, that's probably, you guys heard of a lot of cases, you know, it's the old legacy pollutant. They are banned, they're not used any longer, but because of its persistence and also bioaccumulation, biomagnification, their existence in the environment is actually really, really high. And especially in the ocean environment, it's in the coastal environments, it's known to be pretty high. And the San Diego Bay, and it's known to have this pollution as well. So what about this PCB pollution in, you know, among these three marinas? So it's basically same questions. What is the spatial distribution? Is there any hotspots possibly associated with the boat persons or something other environmental factors there? And then what about those PCBs pose a potential risk to aquatic organisms? Pretty much a very parallel study to the PAH study just I presented. So here, same, like three sites. So again, the Harbor Island East has the highest concentration among the three marinas, among the three sites. And then the Shelter Island and the Harbor Island West are pretty much similar, have a similar concentrations. The highest PCB concentration was found in Harbor Island East 01 and the Harbor Island East 02. Very interesting, Harbor Island East 01, that station is close to a main drainage outflow, which also we found in very high pH concentration too. So these are the kind of like a PCB concentrations. It's the sediment concentration in this three marina sites, and then compared to other harbor samples in the world. You know, it's not nation in the US and then other world locations as well. And what are these concentrations are kind of a comparable, or it's high or low and things like that. If you're looking at that kind of like a table 3 here, and then the Harbor Island East, it definitely is in the kind of high kind of concentration category compared to the other harbor, you know, the locations. Same thing, so that we tried to put this spatial distribution by using the model and the concentrations data. And looking at each marinas, you can see that like the spatial gradient, you know, where is the hotspots, and then you know, you're looking at that kind of a concentrations gradients in each marina. So basically, what we see is here, again, those are not necessarily correlated, associated with the boat activities, found in the copper study in the previous study, rather than they're much more kind of like possibly related to more like again, more surroundings, the urbanization, or possibly more like a runoff, like outfalls and things like that. So it's the PCB concentrations definitely we found the high hotspots, but they're not necessarily correlated with the boat activities. It's more related to the storm drain outfall and then possibly more historical contamination activities. So we kind of discussed about that kind of stuff in the paper, and I hope you, if you're interested in, please read those papers and refer the papers. Okay, so what about the PCB's biological risk evaluation? Just like, what we kind of discussed about the PAHs. We see that, overall total PCB concentrations were largely above that, the ERL, the lowest affected level. None of the sites in Shelter Island exceeded the ERM, the median level of causing the effects. But in Harbor Island West, only one site showed that PCB levels higher than the ERM. And then in contrast, in Harbor Island East, most of the sites exceeded the ERM, so suggesting a potential toxicity to aquatic organisms. So basically what our findings is the Harbor Island East has the potential toxicity, from the PCB pollution to the aquatic organisms. So I was thinking about more like, my interest, than our lab, what we're doing here, so we kind of like found this, like some sites or hotspots for one of them or both of them, the both PAHs and PCBs. It's kind of wonder if there's any additive biological toxicological effects. That's kind of like a question for future study. Also, another thing is that, of course, are there any other contaminants in the marinas? It's kind of like always the questions. You hear a lot of like new, novel, or contaminants of emerging concerns, and how we can find those chemical contaminants. Maybe more proactively. What products are used in the products possibly leaking some certain chemicals and then causing unexpected consequences, things like that. So what we're doing in our lab, then we do implement non-targeted analytical approach. This is it's a pretty new, novel approach for environmental monitoring, but we have been working on this non-targeted analytical approach for more than 10 years. We are actually pretty successful in terms of the finding new or unrecognized chemical contaminants in environments. And then that actually lead us to the further study those new novel contaminants. In addition, also that kind of helps us to understand more comprehensive, what's the status of the contaminants. So that really helps us our research in microplastics, and then and also other types of not recently, we've been working on many legacy pollutants, including DDT, and then also offshore DDT pollution recently discovered in Southern California Bight. We're working on kind of a overall this environmental contaminants, by using this new type of analytical approach. And also it's kind of very important, the sediments and water and air, there's all three matrices are very important for source investigation when we try to find out where this certain contaminants are coming from. I'm going to end my presentation at this point.
Thank you. That was very interesting. We have some time for some questions if anyone would like to have questions or comments.
This is Ray with Orange County Coastkeeper. Excellent presentation. I was just noticing that you mentioned the parking lots a lot as the potential source. There's a giant airport right there. I'm sure you looked at that. Maybe there's no drainage into this area from the airport.
That's definitely. I mean, the PAHs, the airplanes are source of the PAHs as well, so there's quite a bit of like the paper that we actually looking at all this PAHs competition. I mentioned that we analyzed 36 PAHs, so that competition also we see some differences from certain sites. It's kind of most sampling stations have a similar competition, but some sites actually show very different chemical composition. One of the sites that I showed the highest concentration, the Harbor Island East, which is very close to that, basically the parking lot and then the stormwater drain, that has a very different chemical composition. So yeah.
Hey, I have a question regarding the PCBs in the storm drain outlets. Is it your understanding that there's still a lot of PCBs from the watershed that are being washed down in stormwater runoff, or is this mostly from past legacy events?
It's probably definitely past the legacy events, but those chemicals are so persistent, so it's possibly we're still getting those things from the watershed. I think I think that that it's very well known, and actually the Superfund site up there, more like Puget Sound in Washington State, and they receive constantly those PCBs still, from their watersheds. Yep.
Hi, this is Karen Holman over here at the Port of San Diego. I was wondering if I could comment. Can you all hear me?
Yes.
So I'm trying to figure out a way to raise hand, and I'm sorry, I just cut in, but I can't find the raise hand. And to be honest, I'm not even sure how to put my camera on. So I apologize on that. I do want to weigh in a little bit. Thanks, for the presentation. I do want to weigh in just for some of the questions from Ray and Vanessa on that. The port and the regional board have been doing a lot of work around the bay, to the point on the PAHs and PCBs coming from upland versus legacy. Yeah, we're finding that a majority of it is still legacy pollution. We're continuing to do work. There's a lot of other sources in that Harbor Island East area. And we've been doing studies. There's some investigative orders that are out there and other places in the bay. So in terms of, the work that's been going on, we've been studying it. There's cleanup orders, there's investigation orders in various locations. The key take home that I got from yours is, consistent with what we've found. Looks like Harbor East has an area of hotspot, but doesn't seem to be related to marinas or boating activities. And that's kind of what we've found. Now, like I said, we've got a lot of information. We do a regional harbor monitoring program that assesses, and I think since the data that you all collected in 2014, 2015, we've done a couple of data collections bay-wide to assess not just metals, but PCBs and PAHs and sediments and water quality testing. So we've got a pretty robust data set of of information throughout the bay, looking at marinas, freshwater input, industrial areas, as well as some more focused studies on some of these areas that would be kind of around, hotspots or cleanup areas where we've been doing more specific investigations. So, if I will say to the group, if anyone has any more questions or more details that they'd like, there's a lot of good information on GeoTracker on the regional board's website. We also have information internally, and I'd encourage you all to reach out to me if you have any more specific questions. I mean, certainly more for Una on her program, but if there's other questions related to, some of the legacy contamination or anything else for San Diego Bay, feel free to reach out to me as well. I could be a resource if you have other questions. That's all. Thanks.
Well, thanks for that, Karen. I'll make sure to make a note of that with your contact info in the notes so people can get a hold of you.
Yeah, excellent. Thank you, Vanessa.
Mm-hmm. Any other questions or comments? Well, not hearing any, let's move to the meeting wrap up then. If anyone has any additional announcements that came to mind during the meeting, now would be the time for that. If not, I want to say again that I'm going to be posting meeting notes and materials and the video of the meeting on the Coastal Commission's Marinas webpage soon. And we'd also like to ask if you have any ideas for topics for the next meeting, which will probably be in June or July. If you can have any suggestions now or be thinking about it, and let me know if you would like to present on a topic or know a topic that you would like to hear more about. Just please let me know about that. So any suggestions for topics that you'd like to hear about or particular speakers? Not yet? Okay, well, keep it in mind. And this was a very interesting set of talks today. So we're hoping to get more interesting ones for our next meeting as well. So I think that's about it. Unless someone else has anything to add, we can go ahead and conclude our meeting. A few minutes early even. Okay, well, thank you all very much for attending, and we hope to see you at the next meeting. Thanks a lot.
Thank you. Thanks, Vanessa.
Bye.
Happy holidays, everyone.
Happy holidays.
Thank you. Bye-bye.
Bye-bye.
Bye.